Well, good day, ladies and gentlemen, and welcome to our second section, 2.1b. This is going to be application of linear equations. Another way to write that is word problems. But before we go any further, a couple of you have asked me, I guess you've been disappointed to see that I don't actually appear in these videos, just my hand appears. So you've asked what I look like, and I think that's a legitimate question to want to know what your instructor looks like. I have a couple of pictures of me. One is of me at the beginning of last semester, before all this COVID-19 stuff happened. This is just a picture that my wife took of me a couple of months ago. Some people say I look like somebody famous. I'm not sure. I think it's Bernie Sanders or somebody. But anyway, that's... but since the COVID-19, my wife said it has really affected me since I had to do the online, and it really stressed me out. I don't think so. But here's what I look like presently. Personally, I don't see a lot of difference. I guess I could do a little bit more hair care here, but it has changed me significantly, and I personally don't see the difference in my picture, but I just thought you ought to know what your instructor looks like. But all right, here's what we're going to do. We're going to start on this section on word problems, and instead of giving you notes on word problems, that's kind of counterproductive. Basically, what you need to know is how to work the word problems. So we are going to simply work examples of Hawk's word problems. I took this right off of the Hawk site. So your problem should look significantly like this problem. Each of your problems should look basically like this. Here's the first one. It says, solve the following formula for the indicated variable. First of all, a formula. Formulas are multivariable equations. Like here's an old formula. You've seen it before. E equals m times c squared. Multivariables. Different variables. Here's a more familiar formula. C equals 2 pi r. And we're looking to solve for r. Some of you know what this is. This is the formula for the circumference of a circle. The circumference is the distance around a circle, and it can be measured as 2 times the irrational number pi, about 3.14, times the radius. So the circumference can be found by multiplying a constant, 2 pi, times this other variable, radius. Now we're looking to solve this guy for r. And if I want to solve something for r, that means I want to write it as r equals. Solve it for r is by itself. Right now, as you can see, r is being multiplied by 2 times pi. To undo a multiplication, I do the reciprocal or opposite operation, which is division. So whatever r is being multiplied by, I'm going to divide both sides by that same value. We say these guys cancel. What actually happens is a number over itself is 1. 1 times r is just r. So r is c over 2 pi. Again, to solve something for a variable means to express it as itself. R equals. And there's my first problem. All right, second problem. 2 trucks leave a warehouse at the same time. A problem like this has been going around the American math community for literally centuries. 200 years ago, it was 2 stagecoaches left St. Louis, one going east, one going west. Back in the early 1900s, it was 2 trains left Chicago. Now here we go, 2 trucks leave a warehouse at the same time. One travels due south, average speed of 49 miles per hour. The other travels due north, average speed of 55 miles per hour. After how many hours will the 2 trucks be 260 miles apart? This is an instance in which an old principle becomes visible, and that is, hey, it's good to draw a little picture if you can. It's good to give a little illustration of your word problem. We are visual people, and if we can see a visual presentation of what's going on here, we are more likely to understand it. All right, here we go. Here's the warehouse. One travels due south at an average speed of 49 miles per hour. So this guy heads south, 49 miles per hour. Why so slow? Well, average speed. Lots of stops. Stops to pick stuff up, stops to deliver things, stop at Dairy Queen for a chocolate stream blizzard, stops all over the place. So because of the stops, you have an average speed. The other travels due north, average speed of 55 miles per hour. Now here's where the diagram is going to help. Notice this. After 1 hour, the distance between these 2 trucks is 55 plus 49. The distance between these 2 guys is that plus that. It's 104 miles. So here's how I can write it. And I'm going to write something in the form of what's called a proportion. Proportion is simply a fraction equals a fraction. And I'm going to create a fraction. 1 hour, after 1 hour, these trucks are 104 miles apart. After 1 hour, they're 104 miles apart. The question is, how many hours will the 2 trucks be 260 miles apart? So another part of my fraction is 260 miles. Another part of my proportion is 260 miles. Where does it go? Here or here? This is the hours part. This is the miles part. So 260 miles goes in the denominator. And I'm asked how many hours. That means I don't know. X hours. Now here's the good thing about proportions. Since they have identical units, hours over miles, we don't have to worry about the units. They cancel out. And so my proportion boils down to 1 over equals x over 260. 1 over 104 equals x over 260. Do you know how to find the missing part of a proportion when you have 3 parts given and 1 part missing? You simply cross multiply. X times 104 is 104x. 260 times 1 is 260. Benefit of cross multiplying, hey, no more fractions. Well, this is going to be simple, isn't it? All I have to do is divide both sides by 104. And using my handy-dandy scientific calculator, 260 divide 104. Wonder what that is. 2.5 it says. So after 2.5 hours, the two trucks are 260 miles apart. All right, so again, your problem is going to be similar. Your distances are going to be, or your speeds are going to be different for your two trucks. That means your total is going to be different. Maybe your total number of miles apart after so many hours is going to be different, but it's going to work exactly the same way. Hours to miles equal hours to miles. Set up that proportion, cross multiply, and away you go. All right. Hey, you got another formula. Solve the following formula for the indicated variable. This says v squared equals v sub 0 squared plus 2ax. And I want to solve the thing for that feller right there, x. Which means I want to get it all by itself. Right now it's being multiplied by 2a and it's being added to v sub 0 squared. All right, first thing I want to do is get the term, that's the part of the equation. This has three terms. Get the term involving my variable by itself. So this is the part I want to get by itself. Why? Because that's the term, that's the part that involves the variable I'm interested in. So I got to get rid of this guy. How do you get rid of something that's added to something? Well, you subtract it from both sides. And I get v squared minus v sub 0 squared. And you should note, you have, when you're writing out your answer and you want to write v sub 0, that is actually an option in your keyboard. When you're working these problems and you want to write some stuff, there's something called a keyboard. Click on that rascal and all sorts of options will show up. This is one of them, v and v sub 0. Maybe not v, because you can do that with your own keyboard, but your Hawk's keyboard has a v sub 0, so that's available to you. Now I want to get the x by itself. This should look familiar. This looks like circumference equal 2 times pi times r. Looks very similar, so I'm going to divide both sides by 2a. And what do you know? I got it. X is this fraction, and one of your keyboard options is to create a fraction. So I create the fraction, write in v squared minus, put in my v sub 0, it's also squared, over 2a. So your keyboard will give you options like, hey, create a fraction. Your keyboard will give you options like, hey, put an exponent on it. And so you will choose those options through your keyboard. All right, solve the following formula for the indicated variable. Here's my formula. I want to solve this guy for f. Some of you know what this is. This is the translation of temperatures from one degree of measuring to the other, from Celsius or centigrade to Fahrenheit. This is the guy we use, Fahrenheit. This is the metric version, which is Celsius. Now, if you should look at international weather forecast, oftentimes the temperature in Belgium or Paris or Spain is given in Celsius. And so don't be alarmed when you see on a summer day that the temperature in Paris is a scorching 33 degrees. Seems pretty cold to me until I realize, hey, they're not talking about my scale of temperature, they're talking about their own. So here's how we can change from 1 to the other. Well, what if I wanted to express this as Fahrenheit equals? In other words, solve for F. Well, I'm going to have to get the F all by itself. Right now it's in this quantity right here in parentheses, and it's also being multiplied by a fraction. Well, here's a legitimate question you're going to have to face in multiple times in the future. Hey, how do I get rid of a fraction how do I deal with a fraction that's being multiplied by something I'm interested in solving? And the simple answer is multiply both sides by the reciprocal of that fraction. And you know how to get a typical reciprocal, just flip the fraction upside down. So my first step is to multiply both sides by the reciprocal of 5/9. And you know what happens when I multiply by reciprocals. I get 45 over 45. I get 1. What we say is they cancel. What we mean is they multiply to give 1. That's why we do it. So I get 9/5 C is F minus 32. Hey, that simplified things nicely. Now all I have to do is get rid of the minus 32 by doing the opposite. And I get 9/5 C plus 32 equals Fahrenheit. Again, I focused on the area of my formula that involved the part that I'm interested in solving for. I isolated it, and there you go. All right, here we go. Reuben decided to leave a 16% tip. Reuben leaving a tip. That makes me hungry for a sandwich right now. I'll fight the urge. All right. Reuben decides to leave a 16% tip after eating dinner at Sun Bistro. If the bill is $20.32, how much should he pay? Now, first time I worked this problem, I got it wrong. Why did I get it wrong? Because I misunderstood what they meant when they said, how much should he pay? I thought they meant how much should he pay for the tip. But what they're looking for here is the total payment, which means the bill plus the tip. So they want the total he's going to be out of pocket here when they say how much should he pay. All right. So the way I'm going to find 16% of $20.32 is to translate this into mathematical symbols. Now 16%, if I want to do that in my calculator, I'm going to change 16% to a decimal. Now percent, the root of the word percent is cent, like centurion or century or centipede, which means 100. So 16% means 16 per 100. And if I put that into my calculator, it'll give me the decimal representation of 16%, 0.16. Now the way to do it is to move my decimal point 2 places to the left to move from 16% to 0.16. Either way, use your calculator to find it or use your moving the decimal strategy. So 16% means 0.16 of mathematically translated means multiplication. So I'm going to multiply 0.16 times 20.32. Again, I'm going to use my handy dandy calculator. 20.32 times 0.16 is, and I get 3.2512. This is a dollar amount. $3.2512. But I want to round to the nearest cent, which means I want to express it as something like $3.25. Well, do I round up or do I leave it alone? Here's where I go to the next significant figure, which is a 1 here. If this is 5 or greater, I round this to the I round it up 1, 3.26. If it is 0 through 4, if it's less than 5, I leave this alone. It is 0 through 4, so don't worry about this. This is approximately $3.25. So my total payment is $2.32. I'm sorry, $20.32. Didn't get off that cheaply. Add my tip, $3.25, and I get 7.5. Total payment of $23.57. By the way, ladies and gentlemen, if you go out to eat in these days during the COVID recovery, tip your waiter and your waitress nicely. They've been having an unasked for vacation. All right, next one. Find 3 consecutive integers whose sum is 267. All right, first of all, 3 consecutive integers. Integers are things like 5, 6, and 7. Consecutive means in a row, so 5, 6, and 7, 123, 124, 125. So it's just 3 in a row, 3 consecutive integers, 3 integers in a row whose sum is, that means added up, right? 267. So what I got is, and there's a variety of ways to do this. Some of you have used the n plus 1, n plus 2 approach. I use more of a yeoman's approach, a strong arm approach. I've got these 3 consecutive integers that add to 267. Now here's how I'm going to think about this. This middle number is the average of my 3 numbers. This turns out to be the average of my 3 numbers. So if I want to find my middle number, I get the average. The way you find an average is you add these things up. That's already been added for me. Thank you very much. The way you get the average of 3 numbers is you add them up and divide by however many numbers you got. I got 3. So to find this average, I'm going to go 267 divided by 3. Handy dandy calculator. 267 divide 3 is, what do you know? It's 89. When I find the average of my 3 consecutive integers, I find the middle number. Now this isn't going to be hard from now on. If I found the middle number, then the next higher number is 90. The next lower number is 88. I got my 3 consecutive integers. By the way, be sure and look for the answer to the question that is being asked. This question is find 3 integers, so I got to find all 3. Sometimes it will say 3 consecutive integers add to 267. Find the largest of the 3. So you're going to have to find this guy, find the other 2, and write the largest, or the smallest. So be sure and find the answer to the question that is being asked. Hey, what if it said the sum of 5 consecutive integers is something? What if it says the sum of 5 consecutive integers is 185? What would you do? Well, exactly the same thing, just a little variation. I don't have 3 numbers added this time. I have 5 added. So I will do exactly the same to find the middle number. That's the average. I'm going to go 185 divided by, got 5 numbers, 185 divided by 5. Let's see. 185 divided 5 is 37. So I have just found my middle number, 37. The others are easy. 38, 39, 36, 35. That's pretty easy, huh? This strategy works very nicely when you have an 1, 2, 3, 1, 2, 3, 4, 5 odd number of consecutive integers. I mean, think about it. What if you had 4 consecutive integers add to 178? Well, let's get the there is no middle number. There is no middle number. I got 2 middle numbers, you could say. There is no number in the middle because I have an even number of integers. So I'm going to have to do a slightly different strategy, but it's going to start off the same way. I'm first of all going to find the average, but guess where the average is? The average is right in between my middle numbers. To find the average of 4 things added that give 178, I'm going to go 178 divided by 4. Let's see what that gives me. 178 divided 4 is 44.5. Hey, that's not even an integer. 44.5 is my middle number, my average. Hey, it's going to be easy. My next highest integer is 45. After that, 46. My next lowest integer is 44 and 43. So I still do exactly the same thing, except I'm not finding a middle number. Since I don't have a middle number, I'm finding the middle of my 2 numbers. Still do the same thing. Total divided by the number of integers you're interested in, that gives you your average. All right. A lot of online shopping now without shipping costs. A helmet costs $56.48 from a particular online dealer. If Jordan pays $61.11 for the helmet, including shipping, how much did the shipping cost? Well, this is pretty straightforward. The total, obviously, equals the item plus the shipping. The total, I'm told, is $61.11. The item cost $56.48. Plus, indicate the shipping with an S. How much did the shipping cost? Well, to get S by itself, I got to subtract. Using my handy-dandy calculator, because I don't want to break a sweat here. Minus $56.48. And I get that $4.63 is the very reasonable shipping. Not too bad. All right, solve the following formula, another formula for the indicated variable. Here's my formula. One good thing about solving formulas is you don't have to know what they represent. I don't have to know what this represents to solve this guy for B. But it doesn't hurt. Some of you with some geometry expertise will notice that this is the formula for the area of a particular geometric figure. It's got a B, capital B, and a little b. You know what that is? It's this guy. It's a trapezoid, a four-sided figure, two sides of which are parallel, two sides of which are not. This is my major base. This is my minor base. This perpendicular distance here is the height. And I can find the area by multiplying 1/2 times the sum of my bases times the height. You know, again, you don't have to know that. But I want to get this guy by itself. Let's go back to our strategy. Isolate the part that involves the variable that I'm interested in. So I need to isolate this parentheses. Hey, look at there, fraction. So the first thing I think I'll choose to do is multiply both sides by 2/1. And since this is not a fraction, I can just multiply by 2 on this left side. So 2a equals, and these cancel. That's what reciprocals do. They multiply to 1. I still have my b plus b in parentheses until I get rid of this h. How you get rid of an h that's multiplied? Why, you divide by h. So I get 2a over h. And let's see, b plus b. I want to solve for the little b, so I'm going to subtract big B from both sides. And I get little b is 2a over h. Got to use my keyboard and my fraction option, minus b. Not too bad. Isolate the part of the formula that involves your particular variable, the variable you're interested in. All right, two brothers, Mark and Walter, each inherit $25,000. Hey, congratulations, Mark and Walter. Mark invests his inheritance in a savings account with an annual return of 2%. Walter invests his inheritance in a CD paying 6% annually. How much more money than Mark does Walter have after 1 year? All right, this involves a formula also. I don't see a formula. Yeah, you got to come up with it. Here's why we're doing some notes before we work these problems. There is a formula for finding interest. And it goes like this. I equals P times R times T. This is my interest, the amount of money that somebody gives me for loaning them some money. So if I loan a bank $25,000, they promise to give me back some money plus my original amount after a particular length of time. The amount that I give them is the principal. R stands for the rate, and T stands for time in years. So in a particular instance like this, I fill in all the parts that I know and then find the part that I don't know. So for instance, if I filled in everything except the little b, I would fill in everything and then find out what the little b is. In this case, I don't know the interest. I do know the principal. It's $25,000. I do know the rate. It is both 2% and 6%. And I do know the time. It's 1 year. Now, they're both going to be making an investment. So I'm going to indicate my two investments differently. One is for Mark. One is for Walter. I could call it I1 and I2. I'm going to call it I sub M. Hey, that lets me know this is the investment for Mark. That's equal to principal, $25,000, times the rate. Let's see what Mark's rate is. Mark invests his at 2%. Do I write 2? No, I do not. I change 2%. That's 2 over 100. That's 0.02. And the number of years is 1. The interest for old Walter, same principal. He's still got $25,000. He, on the other hand, invests at 6%. Likewise for 1 year. So I'm going to multiply 25,000 times 0.02 and discover that that is $500. And you could multiply by 1 if you enjoy multiplying by 1. For Walter, it's 25,000 times 0.06. What do you know? It's $1,500. Ta-da, I'm finished. Oh, no, I'm not, because the question is, how much more money does Mark have than Walter? So to find out how much more, I'm going to subtract 1,500. Be sure and answer the question that is being asked of you. And there's my answer. He got $1,000 more. All right, ladies and gentlemen. Good luck to you on working your word problems, and I will post the video and these notes on Blackboard content. Keep up the good work.